we're asked to add these two terms. Now, when we look at these terms originally, first of all, make sure you realize that this right here, these are part of the radical, right? When I look at these are not like terms, right? Because, well, they're both third roots. They have different terms underneath the radical. But that doesn't mean we're stuck. We have to first see if we can. So when I look here, this 3 here, if either of these are below 3, I can't do anything, but I can if it's above 3. So when I look right here at this one, okay, this is x to the third, xy squared. Because what I did is I took apart this 4, I did a 3 and a 1, because then these two are a perfect cube. Now this one over here, this is 7x, the third root of xy squared. I know I can't do anything because 1 and 2 are both smaller than 3, so I can't. But this right here, this chunk, I can take the root of. So what I'm really doing is I'm doing two parts. I'm doing this, and then I'm leaving everything else here, right? So what I'm going to end up with? Well, I'm going to end up with an x, because those cancel each other out, a 3xy squared plus 7x 3xy squared. So now when I look at these are now like terms because they're both third roots, right? And everything underneath them, x, y squared, y squared. Now, this x out in front also must match because it's a variable as well, but it does too. So now these are complete like terms, which means I can add their coefficients. This doesn't have one, so it's a 1. So this is 8x third root of x, y squared. The rule is everything has to match. If it doesn't, you can't add it, okay? So make sure you're paying attention to it. What's under the radical what matters, what's in front of the radical matters, all of that matters whether you can add it or not. But you can always look to see, can I simplify it? And the rule for simplifying radicals is if the root, so in this case 3, or obviously this would be a 2, is larger than the exponent, you can break it down.